Okay, ladies and gentlemen, let's discuss the last piece of the puzzle in the logistic regression. Okay, so go ahead and open up jump file, which we were working on in the last week or so. Okay, it was, I believe, Universal Bank CT, right? Okay, so here is my file, and again, what I'm predicting really is which customers of the bank are likely to get a loan when they are offered a loan, right, independently. And I'm using all the variables, right, that I have. So let's quickly build a model one last time, right? So personal loan is my target Y, okay? And the rest of the variables are my predictors. So I'm going to add them to the, the model, right? And then I pick the level, which level I'm targeting, right? The personal loan variable has two levels, 0 and 1. So I'm picking 1 because I'm interested primarily in people who will pick a loan from the bank. And then I run the model, and here is my output, okay? What does the output say? Output says that income, right there, is the most significant variable which contributes the most, right? And we discussed that that's probably true, right? The more money people are making, the higher is the likelihood that they will agree to a loan from the bank. And then education level seems to be number 2, whether or not they have CD account, family size, etc. Okay? So we can see that age apparently is not contributing much, right? And these are p-values, by the way. The variables are listed in the order of their decreasing p-values, right? No, increasing p-values, okay? And so which ones are we dumping? Which variables do we have to eliminate? The ones that are not contributing significantly, right, statistically. That means high p-value, right? Remember what we're testing. Null hypothesis would be that the slope of this variable can be set to 0, therefore eliminating that from the model, right? And the alternative is slope cannot be set to 0, so the variable is significant. So for us to reject the null in favor of alternative, for the variable to be significant, we have to have low p-values, right? So anything with high p-value needs to go. So which means that mortgage balance, I can select them all, right? Experience and the age, I can eliminate from the model altogether, okay? All right, but what I wanted to do today is, not to answer that one. All right, is to take a look at these slopes of the variables, okay? So here is my model essentially. Intercept is minus 9.634 minus, so I'm going to record things, or you know what, better yet, let's go ahead and save the formula. Let's go ahead and save this formula into the data file and then kind of discuss the slopes, okay? So what I'm going to do is, in the red triangle, I'm going to say probability formula, okay? And what it will create is a few columns, really, in my data file, right there, okay? So there is column lean, which stands for linear part of my logistic regression, okay? And then based on this lean, it predicts probability of yes, or probability of 1, right? Then probability of no, or probability of 0, and also, based on these two probabilities, how do we classify this observation? Is it a 1 or is it a 0, right? Okay, so let's take a look at this part, linear regression, okay? So I'm going to double click on the column and then ask for the formula, right? So here is basically my formula. Remember we discussed what happens if the slope for the variable is positive. How does that affect the odds of getting a loan, or, which is almost the same thing, probability of getting a loan? The slope is positive, the odds are getting up or down? Up, right? And vice versa, okay? So, for example, income, as we discussed, increase in income results in higher odds of accepting a loan, or higher probability of accepting a loan, okay? At the same time, you can see that, for example, let's see. Let's look at the variable age. Age actually is not significant, right? It's not statistically significant, but let's use it for discussion anyway. Okay. So here's what I'm going to do. I'm going to go back to my output. Okay. And from the red triangle menu, I'm going to ask for the unit odds ratio. Okay. So from the red triangle, odds ratios right there. Okay. Now, odds ratios, there are three parts to the odds ratios, okay, in my output. One of them is unit odds ratio, another is range, which we're not going to use a lot actually, and this one deals with the only variable, with the only categorical variable that we have, which is education. But let's discuss continuous variables first, okay? What we did a couple of classes ago is we actually interpreted the slope of the equation. And here, let's do it again. For the income, for example. For the income, the slope of the equation is 1.062. Okay? So I'm going to write that down. So slope for the income is 1.0620. Okay? Now, my equation looks something like that. Natural log of odds is equal to beta 0 plus beta 1 times x1, which is actually, well, let's use income as beta 1, right? So my slope is 1.0620 times the income value. And then I add the rest of the variables, right? So I add beta 2x2, beta 3x3, etc. Okay? So the reason why it's called reminder, okay, you may or may not remember, but the reason why it's called unit odds ratio is the following. If I go from income to income plus 1, okay? In other words, I'm increasing my independent predictor by 1, okay? What happens with odds? So this, I'm going to call them natural log of odds when my income was old, before it was raised by $1,000, right? So now my new odds, when income becomes income plus 1, okay, are same everything, same slope, right? Same, let me write down beta 2x2, beta 3x3, right? So all of that is the same, but here I have 1.0620 times a new value, right? It's going to become income plus 1, okay? So therefore, what will happen is beta 0 plus 1.062 times income, old level, plus beta 2x2 plus beta 3x3, plus the rest of them, and then finally this unit that I added, my income plus 1, right, gives me 1.062 into the equation. Okay? So that's what's going to happen. Okay? And now I'm going to take this new odds and subtract the old odds. Okay? So, therefore, it's going to look like that. Natural log of my odds for income plus 1 minus natural log of odds when my income was at the old level before the raise, right? Equals to, let's go back, all right? If I take the difference, then beta 0 will cancel out, right? 1.062 and 1.062 income will cancel out. Okay? Beta 0 canceled out. Okay? And beta 2x2, beta 3x3, all these things cancel out. And that would be the only part remaining, right? So therefore, here, right? 1.062. And after that, I do very simple trick, right? I raise e to the power left-hand side and also to the power right-hand side, okay? And because they're equal, e has to be equal as well, right? E to the power natural log of odds new, let me call it new odds, divided by e to the power natural log odds old, okay, equal to e to the power 1.062. So that basically is my slope for the income, right? Beta for income. Okay? Now, when I raise e to the power natural log of something, what am I getting? E and natural log are reverse operations, right? So therefore, I'm getting odds and odds, right? So therefore, this is what I call a unit odds ratio, right? When I raise the income by 1, I get the odds ratio of new odds divided by old odds, right? So this is the same thing as odds at income plus 1 level divided by odds at old income level, okay? And that's e to the power 1.062. We discussed that before, I'm just reminding you, okay? So now let's go ahead and calculate how much is e to the power 1.062, okay? So I'm going to fire up Excel, okay? And after that, Emily, what are you typing? Are you typing the notes? I can hear that. It's like striking me in the head. Okay, so equals to exp, right? Exponent of where is my slope? My slope is right here, right? For income. Hold on, did I incorrectly read the slope? Why was it 1.06? Where did I get that?
You got that from the odds. That one?
Oh, from this part, right? Oh, okay. Forget about that. Okay, so I was supposed to use slope right here, right? I basically looked at the wrong portion of my output. Okay, so this 1.062 supposed to be this one. 0.0601829, right? So let's go ahead and that's what becomes my 1.062, right? E to the power slope, okay? Sorry about the confusion. So I have to raise my e to the power 0.06018297. Oops, 8297. Okay, and there you go. That's your odds ratio, okay? 1.062. And remember how we interpreted that back then. We said the meaning of that is, let me go back to, the meaning of that is odds under the new income plus 1 divided by odds under the old income are equal to 1 point, so this part is 0.0601, right? And that is equal to 1.062. The meaning of that is that the new odds, when my income goes up by 1, are 6.2% higher than the old odds. Remember how we arrived to that? To this interpretation? This portion, basically, of my odds ratio tells me that my new odds are 6.2% higher than the old odds. Agree? Is it obvious? If one number divided by another number is equal to 1.062, it means that the higher number is 6.2% bigger than the lower number. Agree? And that happens if my slope is positive, right? The odds are going up. What did we discuss about the negative slopes? The negative slopes reduce the odds, right? Reduce the probability. So let's do the same trick with one of the variables that has a negative slope, okay? So here's what I'm going to do. Let me pick, like I said, age. Even though age is not a significant variable, right, and technically we can dump it, that's all right. So here is the slope for the age, right? Now let's make sure that we're using the right thing. Age is minus 0.0359, right? So that means that as people get older, they're less likely to get a loan from the bank, even if when they are offered, right? So I'm not going to go through the same procedure. It's essentially going to give you the same result, right? What result? If I take odds for age plus 1 and divide it by the odds for the age, right? It's going to be e to the power what? the slope from my output, correct? Just like what I had for income. No difference, right? It's the same exact thing. The only difference is the slope is negative, right? So age has minus 0.0359, and I'm going to do that, minus 0.0359, okay? So let's compute that thing, for crying out loud, okay? So here, I'm going to do it in Excel again. Exponent of minus 0.0359174. Okay. And the odds ratio is less than 1, right? Before that, when we dealt with income, odds ratio was higher than 1. That's unit odds ratio, right? Now it's lower than 1, which is consistent with what we discussed. If the slope is negative, then the odds are going down, right? So let's actually write that down, 0.9647. 0.9647. And let's discuss by how much odds are going down, right? My previous one, in my previous case, right there, okay, my unit odds ratio was 1.06, so I took this part and I said, well, odds are increasing by 6.2%. When income is getting higher by $1,000, the odds of getting a loan are getting higher by 6.2%, okay? Now, in this case, my interpretation is slightly different, okay? How? Well, here, okay? Let me kind of rewrite this expression like that. Odds for the age plus 1 is equal to odds for the old age before increasing multiplied by 0.9647, okay? And let's do same thing as we did before, okay? So subtract from both parts odds for the age. And minus odds for age, okay? So in the left side, I'm going to have difference of the odds, right? Odds for age plus 1 minus odds for variable age is equal to, and here I'm going to get a negative number, agree? Because from 0.96, effectively I'm subtracting 1, right? So I'm going to get minus 0.0353 times, that's generous, minus 0.0353 times the odds for the variable age, okay? So what does that expression tell me? That expression tells me that my odds are going down by what percentage? By this percentage, right? So the odds for the age plus 1 minus odds for the age, that's the change, right? If age goes up, if a person gets, everything stays the same. Experience, income, education, account balance, the whole 9 yards stay the same, right? But they're getting 1 year older, right? Are they more likely to get a loan from the bank or less likely? That one says less likely, right? By how much? Well, every time when the age of the customer increases by 1, odds are getting reduced by, what does that say? 3.53%. Okay? Does it make sense? For those of you who are actually paying attention, say something. Say meow. There you go. Does that make sense? How from this number, I kind of deduce that it's the same thing as to say odds are getting reduced by 3.53%. It's difference between that number and 1, right? That basically is the amount of change, okay? So income goes up by 1,000, odds are getting higher by 6.2%. Age is going up by 1 year, odds are decreased by 3.53%, okay? That's the interpretation. Michael?
So 1 minus the 0.9647 gives you the 0.0353?
1 minus, so that number essentially is 1 minus 0.9647, right?
And
that's the difference. That's by how much your odds went down.
How much was it?
Yeah. So the frame of reference is always 1, right? 100%. What it was before we got the income increase or age increase, right? It can only go up or down, right? If the slope is positive, it goes up. And then the ratio will tell you precisely by what percentage. But if the slope is negative in your model, then you have to subtract that from 1, and that will give you by how many percent, so to speak, it goes down, right? And that's why it's called unit odds ratio, because it all refers to variable plus 1 odds divided by the initial value of variable odds, right? Okay. So that's as far as the continuous variables are concerned. Now, let's take a look, ladies and gentlemen, at how the categorical variable is being handled. Remember, what was the categorical variable in this in this specific file? The only categorical variable in this file was
The loan.
the what?
The loans. The personal loan.
The loan, yeah, the target, obviously, right? Target, when you're dealing with logistic regression, target always supposed to be categorical. But one of our predictors was categorical. What was it? Education, right? Education was either 1 undergrad or 2 masters or 3 PhD, JD, some doctorate kind of thing, right? And remember what we said. We said that for the education, let's actually go back to the formula. It's going to be easier that way, okay? So if I again double click lean and show the formula, here is my part that deals with education, right? So all the other variables are continuous, right? So I can get income, family size, experience, age, all these things, right? And put them as numbers into this equation. When it comes with education, it's either 1, either 2, or 3, right? And this is what the model does. If the education equals to 1, meaning it's undergraduate, right? The highest level that they achieved was undergraduate, and we subtract 2.676 from the equation, right? If it's master's, graduate degree, we add 1.2889, and if it's PhD, we add 1.3875, okay? So let me write that down, if possible. How am I going to remember that? Okay, so my equation is natural log of odds, right? Equals to whatever the intercept is, whatever first variable slope times the variable second one, etc., right? But when it comes to education, I have to say if it's 1, then minus 2.6, oh gosh, 2.6764. Okay, if it's 2, if it's master's degree, then we have to add 1.2889 plus, right, to 889. And if it's 3, then we have to add plus 1.3 something something. 757. Okay? So, in this case, I don't have a unit ratio, right? Because I don't increase the education by 1. It's a categorical variable, right? I can go from add to add plus 1, right? So, therefore, what I'm going to do is kind of take a look at how these things are interpreted. Suppose I have 2 people, okay? One person is with, let's say, master's degree, right there, okay? And another person is with undergraduate degree, right here. And I want to compare them. If everything else remains the same, they have exactly the same income, age, experience, family, credit card balance, the whole 9 yards. The only difference between them is that one is master, right, graduate degree, number 2, and another is undergraduate, number 1. Who is more likely? Well, we kind of know who is more likely, right? We discussed that. Based on these 3 numbers, what type of education has the highest likelihood of getting the loan from the bank? Which one? 1, 2, or 3? 3, right? It's the most positive number, right? The second highest would be master's, right? Grad. And the third highest would be undergrad, right? So undergrad have the least likelihood or least odds of getting a loan, right? But if I want to quantify, for example, how more likely, what are the odds comparatively speaking, right? The person with a graduate degree, how much are the odds higher for that individual to get a loan from the bank compared to the person with undergraduate? How would I do that? Well, here, okay? Let's compute natural log of odds for a grad, okay? So, and grad means education equals to what? 2. Education equals 2, right? That would be the same enchilada, beta 0 plus beta 1 x1 plus all of them, right? Beta k xk, not plus, but multiplied, right? Xk. And because it's a grad, I have to add that number, right? 1.2889. Agree? So I'm assuming that everything about these two people is exactly the same. Okay? So then I'm going to compute natural log of odds when education equals to 1. So graduate degree, right? Same everything, so therefore I have beta 0, beta 1 x1, etc., beta k xk. But at the end, I have to subtract 2.6764. Correct? And I'm going to do exactly the same trick. Okay? I'm going to subtract the second one from the first one. So therefore, I'm going to have natural log of odds for ed equals 2, master's degree, minus natural log of odds for ed equals 1, undergrad degree. All the betas, all the x's, they cancel out, right? And the only thing that I have is difference between this number and that number. Agree? Yes, yes, yes. Agree. Okay. So therefore, how much is 1.28? Oh, God. I think I need to use Excel, right? Can anybody do that on their computer? I don't know, switch back and forth. Can you do this? 1.2889 minus 2 points, so it's essentially plus, right? 2.6764. Whatever that number turns out to be. It's supposed to be 3 point something, right? 3.9, blah, blah, blah. $9,653. Okay? All right, cool. And I'm going to do exactly the same thing, right? E to the power left side is equal to the e to the power right side, right? Nothing new here. So let me go ahead and erase this portion. Okay. So therefore, on the left side, by the same string of arguments as I did before, I'm going to have, if I take odds for education equal to master's degree divided by the odds for education equal 1 undergraduate degree, it's going to be e to the power 3.9653, or using my good old friend Excel, okay, I'm going to say here, hold on. So here I'm going to do the precise thing, right? Exponentiation of, where was that? Yeah, here. 1.28890087 plus, right? Minus this slope, but this slope is negative, right? So plus 2.6763. Kaboom. 52.74. Okay? So the ratio is 52.74. So what do I say? I say that if two people coming to my bank, okay, and one has a master's degree, another has an undergraduate degree, the odds of master's degree customer taking a loan from my bank are 52.74 times higher, right, than the odds of undergraduate person with the same exact other parameters taking out the loan, right? So it's not exactly a unit increase, right? Well, it kind of is, right? From 1 I go to 2, and 2 is higher, so therefore here is your ratio of odds, okay? So a person with master's degree is has 52 times higher odds of getting a loan out of the bank compared to undergraduate, okay? And I can find that. Does it make sense, first of all, what we just did? Okay. And I can find that in the output, right? So the reason why I showed it to you is, first of all, I wanted you to suffer miserably, but second, I wanted to uncover some of the mysteries behind some of the numbers that we can find in the output. So, can we find this number in the output? Yes, we can. Odds ratio for education. Now note that this unit odds ratio, the only variables that are showing up in this part of my output are the continuous variables, right? Because I go from income to income plus 1, age plus 1, experience to experience plus 1, so I can increase them by 1, right? Here I have only 3 levels, 1, 2, 3. So all I can do is basically take level 1, take level 2, and compute odds ratio for these 2 levels, right? And here's how I interpret that. You see that? It says level 1 divided by level 2, okay? So in my case, I used level education 2 over level for education 1, right? Graduate, master's degree over the undergraduate, right? So therefore, 2 over 1, is that not the same number right there, 52.74? It is, right? It is what we just computed, but now you know how this number comes to existence, right? It's basically e to the power that slope, where is the slopes? E to the power that slope minus that slope, right? And that's what it is. And you can see that it's actually computing for you all kinds of odds ratios, right? 3 versus 1. So you can see that if I'm dealing with a doctorate customer, right, who has a PhD degree, compared to an undergraduate, the odds ratio is even higher, right? They're 58 times. The PhD customer has 58 times higher odds of taking a loan, right? And then, so these are 2 over 1, 3 over 1, and 3 over 2. These are basically reversed, right? So what we have in the first 3 lines, but 1 over. Because why? Well, 2 divided by 1 is 1 over 1 divided by 2, right? So I can basically reverse this odds ratio, right? I can say, well, if I take 1 over and 1 over, right? Then I'm going to get odds for the education equal to 1 divided by odds for the education equals 2, right? And then after that, it's just basically 1 over that number, right? 52.47. Now let's check if the math checks out on this one, right? So if I go ahead and use Excel, so that's my odds for education 2 divided by odds for education 1, right? If I want to flip it, all I have to do is take 1 over that number, and that basically gives me 0.0189. Do I see it right here? I believe so, right? It's right here. 1 over 2, 0.0189. So these numbers, these first 3 numbers are computed, right? And the last 3 numbers basically have to reverse the first 3 to get them, right? So what does that tell us? For example, if I look at 1 versus 2, right? Odds for getting a loan for the undergraduate degree are only, what, close to 2%. That number is 1.9%, right? It's 1.9% for the odds of the customer with the graduate degree. That's what it says, right? Or on the opposite side, for the graduate degree, the odds are 52 times higher than for the undergraduate degree, right? And that's it. That's all I have to say about logistic regression. Finally, we're done with this topic. Any questions, ladies and gentlemen? Complaints, concerns, sarcastic comments, anything hazy, shady? We have upcoming test in about 2 weeks. Not about, exactly 2 weeks, right? Guess what type of problem is going to be on this test? That one, right? And then some. Okay. Well, we have 4 minutes remaining. Do you want to start a new topic? Or do you want to postpone it until Wednesday? Postpone. Okay, so let's officially close the proceedings on logistic regression. And then the next class we're going to start unsupervised learning technique, machine learning technique, of course, right? Which is called clustering analysis.